What if I told you that NASA's rovers on Mars have discovered evidence that could completely rewrite our understanding of the red planet? Beyond finding water or organic compounds, discoveries like pure sulfur crystals that defy expectations, isotopic clues of catastrophic climate shifts, and organic molecules resembling ancient cell fragments suggest something far more profound. These findings aren't isolated, taken together. They reveal a Mars that's more complex and potentially habitable than once thought. Now let's start with something that happened just recently that has NASA scientists completely baffled. In May 2024, NASA's Curiosity rover was exploring when something extraordinary happened. The rover accidentally drove over a rock and cracked it open, revealing bright yellow crystals inside. At first glance, you might think this isn't that big of a deal. But when NASA scientists analyzed these crystals, they made a discovery that defied all expectations. These weren't just any crystals. They were pure elemental sulfur. Elemental sulfur forms under very specific conditions that scientists have never associated with Mars' geological history. It's like finding a tropical rainforest in Antarctica. It just shouldn't be there. But wait, it gets even stranger. This wasn't just one isolated rock. Curiosity discovered an entire field of these bright sulfur rocks scattered across the Martian landscape. NASA's project scientist Ashwin Vasavada described it perfectly when he said finding a field of stones made of pure sulfur is like finding an oasis in the desert. Now, before you start thinking about the rotten egg smell we associate with sulfur, elemental sulfur is actually odorless. But that's not the point. The point is that for pure sulfur to form, you need a very narrow range of environmental conditions. And according to everything we know about Mars' past, those conditions shouldn't have existed in this location. This discovery is forcing scientists to completely rethink what was happening on Mars billions of years ago. Were there geological processes we don't understand? Was the Martian environment more dynamic than we thought? And here's the question that's keeping researchers up at night. What other surprises are waiting to be discovered? But the sulfur crystals are just the beginning. When NASA started digging deeper into Mars' chemical composition, they found something that suggests the red planet experienced a catastrophe so severe it changed everything. What I'm about to tell you might sound like science fiction, but it's backed by hard scientific data from NASA's most advanced instruments. Scientists have discovered isotopic evidence that suggests Mars didn't just gradually lose its atmosphere and water. Instead, it experienced extreme evaporation events so intense they left permanent chemical signatures in the planet's rocks. NASA's Curiosity rover has been analyzing carbon-rich minerals called carbonates found in Gale Crater. These minerals are like time capsules because they preserve signatures of the environments where they formed. And what these carbonates revealed shocked everyone. The isotope values they found point toward extreme amounts of evaporation. We're talking about evaporation so intense that it could only happen under conditions where liquid water existed for very brief periods before being violently stripped away. David Burt from NASA's Goddard Space Flight Center put it perfectly when he said these carbonates likely formed in a climate that could only support transient liquid water. But here's the really disturbing part. The isotopic signatures are unlike anything we see on Earth. Both the carbon and oxygen isotope values are the heaviest ever recorded for any Mars materials. That means whatever process created these signatures was taken to an absolute bad. Now think about this for a moment. Mars might have had oceans, lakes, and rivers billions of years ago. But instead of gradually drying up like we previously thought, something caused such violent evaporation that it left these extreme chemical fingerprints. The light isotopes escaped into the atmosphere while the heavy ones were left behind, creating this permanent record of catastrophe. And if you think that's unsettling, wait until you hear about what Curiosity found when it started looking for signs of ancient life. Because the organic molecules it discovered tell a story that's both exciting and deeply mysterious. NASA's Curiosity rover has discovered the largest organic molecules ever detected on Mars. And when talking about long-chain carbon molecules, they are typically associated with biological processes. Organic molecules don't automatically mean aliens are confirmed, but they are the building blocks of life as we know it. What makes this discovery so significant is that these aren't just simple carbon compounds. We're talking about complex molecules like decane and dodecane, which have 10 and 12 carbon atoms, respectively, all linked together in long chains. These molecules were found in a 3.7 billion-year-old rock nicknamed Cumberland, located in what used to be a dried-up lake bed inside Gale Crater. So we're looking at organic compounds that have somehow survived for nearly 4 billion years in one of the harshest environments in our solar system. But here's where it gets even more intriguing. Some of these organic molecules could actually be fragments of fatty acids, which are often found in the membranes surrounding biological cells. Now, I want to be clear here. This doesn't prove life existed on Mars, but it's exactly the kind of evidence scientists would expect to find if microbial life had once thrived in these ancient lake beds. The problem is, these molecules are so small and the evidence is so subtle that we need much more powerful scientific instruments to make a definitive determination. That's why sample return missions are so crucial. We need to get these rocks back to Earth, where we can analyze them with equipment that's simply too large and complex to send to Mars. And speaking of things that are too complex to fully understand with our current technology, there's something else NASA discovered that's been causing heated debates in the scientific community. Something that suggests Mars history might be even more violent than we imagined. If you're finding these discoveries as mind-blowing as I am, make sure you hit that subscribe button and turn on notifications because we're just getting started with the most mysterious findings from Mars. Some researchers believe they've found evidence of nuclear explosions on Mars. Not natural nuclear reactions, but actual nuclear weapons detonations that occurred 300 million years ago. When NASA's Curiosity rover analyzed the Martian atmosphere, it found unusually high levels of xenon-129, a radioactive isotope. Now, xenon-129 is significant because on Earth, it's primarily produced by nuclear weapon explosions. Every atomic bomb test we've conducted has left traces of this isotope in our atmosphere. The xenon-129 readings on Mars are 2.5 times higher than what we find on Earth, even after 70 years of nuclear testing. Dr. John Brandenburg, a former NASA physicist, has shown this data to several nuclear weapons experts, and they've confirmed that this isotopic signature is consistent with nuclear weapons detonations. Brandenburg's analysis gets even more disturbing. He's identified 2 nuclear hotspots in Mars' northern hemisphere where radiation levels are significantly higher than anywhere else on the planet. But there are no impact craters at these locations, which suggests these weren't asteroid impacts or natural explosions. Instead, the evidence points to air bursts, nuclear explosions that occurred kilometers above the surface. The scale of these theoretical explosions is almost incomprehensible. We're talking about nuclear weapons the size of the Empire State Building, detonated from space with enough power to fundamentally alter Mars' entire biosphere. If this theory is correct, it would mean that any civilization that might have existed on Mars was completely wiped out in an instant. Now, I need to be clear here. This is highly controversial, and many scientists dispute these findings. There are natural processes that could potentially explain some of these isotopic signatures. But the debate itself reveals just how much we still don't understand about Mars' mysterious past. And speaking of mysteries that challenge our understanding, there's another discovery that's forcing scientists to reconsider everything they thought they knew about Mars' geological history. Just when you think Mars can't get any stranger, NASA's Curiosity rover stumbled upon something that looks like it was designed by an alien architect. These are called boxwork formations, and they're unlike anything scientists have seen before on the Red Planet. Intricate networks of ridges form geometric patterns across the Martian landscape, creating what looks like a massive three-dimensional puzzle carved into the rock. These formations are so unusual that when Curiosity first captured images of them, researchers had to completely rethink their theories about Mars' geological processes. On Earth, similar structures form when mineral-rich water flows through rock fractures over millions of years. But the boxwork patterns on Mars are far more complex and extensive than anything we see on our planet. They suggest that Mars once had incredibly active groundwater systems that persisted for much longer periods than previously thought. The chemical composition of these boxwork formations indicates they formed in environments where different types of water with varying mineral content were interacting. This suggests Mars had a much more dynamic hydrological system than we ever imagined, with multiple water sources mixing and creating these intricate mineral deposits. What's keeping scientists up at night is this question. If Mars had such complex water systems, what happened to all that water? And more importantly, could these extensive groundwater networks have provided the perfect environment for microbial life to thrive, even after the surface became uninhabitable? The implications are staggering. These formations might represent some of the best preserved evidence of Mars' ancient habitability. And if life did exist in these underground water systems, traces of it might still be locked away in these mineral structures, waiting to be discovered. But there's another piece of this puzzle that's even more mind-bending. Recent discoveries suggest that Mars' magnetic field history is far more complex than we thought, and this could explain some of the planet's most puzzling features. We've always been told that Mars lost its magnetic field billions of years ago, which allowed solar wind to strip away its atmosphere. But new evidence suggests the story is far more complicated and mysterious than anyone realized. NASA's MAVEN spacecraft has been detecting strange magnetic anomalies scattered across Mars' surface. These aren't just random magnetic signatures. They're organized in patterns that suggest Mars' magnetic field didn't just disappear. Instead, it went through periods of intense instability, switching on and off multiple times throughout the planet's history. Every time Mars' magnetic field reactivated, it would have provided temporary protection from solar radiation. This could have created windows of opportunity where the atmosphere partially recovered and liquid water could exist on the surface again. We might be looking at a Mars that experienced multiple cycles of habitability over hundreds of millions of years. Some of these magnetic anomalies are so strong and localized that they're creating mini-magnetospheres, tiny protective bubbles that are still deflecting solar wind today. It's like Mars is trying to rebuild its magnetic shield, one small section at a time. Dr. Bruce Jakosky from the MAVEN mission described these findings as completely unexpected. The magnetic field patterns don't match any of our models for how planetary magnetism should work. It's as if Mars is following its own rules, defying our understanding of planetary physics. And if you think that's puzzling, there's one more discovery that ties all of these mysteries together in a way that's both fascinating and deeply unsettling. What do you think could explain all these mysterious findings? Are we looking at evidence of natural processes we don't understand, or something else entirely? Let me know your theories in the comments, because this next part is going to challenge everything we thought we knew about our neighboring planet. When you step back and look at all these discoveries together, a disturbing pattern emerges. We have pure sulfur crystals that shouldn't exist, isotopic evidence of catastrophic evaporation events, organic molecules that could be remnants of ancient life, controversial nuclear signatures. Complex boxwork formations indicate extensive water systems, and magnetic field anomalies that defy explanation. Each discovery on its own is puzzling, but together they paint a picture of a Mars that experienced repeated cycles of habitability and catastrophe. This isn't the gradual decline we once imagined. This is a planet that went through violent, dramatic changes that left permanent scars in its geology and atmosphere. Here's what's keeping scientists awake at night. If Mars did experience these catastrophic events, what caused them? Were they internal processes we don't understand, external impacts from space, or something else entirely that we haven't even considered? The implications for astrobiology are staggering. If life did emerge on Mars during its habitable periods, it would have faced extinction-level events multiple times. But life is remarkably resilient. Could microbial communities have survived in underground refuges, waiting for the next habitable period? Could they still be there today, deep beneath the surface where our rovers can't reach? NASA's upcoming missions are specifically designed to answer these questions. The Mars Sample Return mission will bring Martian rocks back to Earth for detailed analysis. The Perseverance rover is already collecting samples that could contain definitive proof of ancient life. And future missions will drill deeper into Mars' subsurface than ever before. Every new discovery raises 10 new questions. Mars isn't just a dead, boring planet. It's a world with a complex, violent, and potentially biological history that we're only beginning to understand. The Red Planet is keeping its secrets, but slowly, piece by piece, we're uncovering the truth. And that truth might be far stranger and more wonderful than we ever dared to imagine. So what do you think? Are we on the verge of discovering that Mars once harbored life? Could it still be harboring life today? Share your thoughts in the comments below. The story of Mars is far from over. In fact, we're just at the beginning of what could be the most important scientific discovery in human history. Every rock sample, every atmospheric reading, every mysterious formation is bringing us closer to answering the ultimate question: are we alone in the universe? What makes these recent discoveries so compelling is that they're not coming from speculation or wishful thinking. This is hard scientific data from some of the most sophisticated instruments ever sent to another planet. NASA's rovers are essentially mobile laboratories. They're equipped with technology that can detect organic compounds at the molecular level and analyze isotopic signatures that reveal Mars' deepest secrets. But here's what's really exciting about the future. China's ambitious Mars exploration program is planning sample return missions by 2028. The European Space Agency's ExoMars rover will drill deeper into the Martian subsurface than any previous mission. And NASA's Artemis program could eventually lead to human missions to Mars, where astronauts could explore these mysterious formations firsthand. Imagine what we might discover when humans are actually walking on Mars, able to make real-time decisions about where to dig, what to sample, and how to investigate these puzzling formations. The boxwork structures alone could keep geologists busy for decades. The sulfur crystal fields might contain clues about Mars' atmospheric history that we can't detect remotely. And those controversial nuclear signatures. Human geologists with advanced equipment could finally settle that debate once and for all. Every single discovery we've discussed today represents years of careful analysis by teams of brilliant scientists. But they also represent the beginning of new questions, new mysteries, and new possibilities for understanding our place in the cosmos. Mars isn't just teaching us about planetary science. It's teaching us about the potential for life to emerge, survive, and possibly thrive in environments we once thought were completely hostile. And if life found a way on Mars, what does that mean for the billions of other planets in our galaxy? The Red Planet's mysterious findings are rewriting textbooks, challenging assumptions, and opening up possibilities that seemed like pure science fiction just a few decades ago. Mars continues to reveal mysteries that challenge our understanding and mark a thrilling era of planetary exploration. Each month brings findings that expand the limits of what we believe possible. If you enjoyed this deep dive into Mars' most puzzling discoveries, there are a few ways to stay connected. Subscribe to the channel and enable notifications so you don't miss future updates on space exploration and science breakthroughs. Don't forget to share this video with others who might be fascinated by Mars. Greater awareness builds more support for upcoming missions. Are you most interested in signs of ancient life, geological phenomena, or future human exploration? Your feedback helps shape future content. Thanks for joining me on this exploration of the Red Planet. Until next time, keep looking up and stay curious. Thanks for being with us. Leave a comment, like to show your support, and remember to hit that subscribe button for more exciting videos. See you next time.